In today's lesson, we're going to take something we learned earlier in the year and apply it to a new concept called systems of equations. So the old concept is what a linear equation is, and a linear equation is just an equation whose line is a straight line on a graph. And a system of equations is pretty simple. It's just a set of two or more linear equations. Now, if we have two or more linear equations, when we graph them, that means we have two or more lines on a graph. So a system of equations is pretty simple. It's just a collection of two or more equations. We recall from earlier in the year something called slope-intercept form, which is y equals mx plus b. The m variable represents the slope, which is the steepness of the line, and the variable b represents the y-intercept, which is where the line crosses the y-axis. So let's go ahead and we'll review how to graph these, and then we'll go from there to graph a system. So I've got the equation y equals negative 2x plus 3. The first thing I'm going to do is identify my slope, which is negative 2. Then I'm going to start by looking for the y-intercept, which in this case is positive 3. So I've got the slope, I've got the y-intercept, now I can graph it, and I like to start with the y-intercept as my starting point, so I'm going to find 3 on the y-axis. So the 3 is right there. And from this point, I'm going to find the next point on the line by using the slope. So I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Negative slopes are always down and to the right. I'm going to draw the line through this, and we should have something that looks like that. It's a pretty straight line. It's pretty steep too. So that's what a negative slope looks like in a linear equation. The next equation that we're going to graph is y equals 1/3 x minus 1. In this problem, the slope is 1/3, which means up 1, right 3. My y-intercept is negative 1. Again, I like to start with the y-intercept, which is at negative 1 on the y-axis. So I'm going to place my point there. And then I'm going to use the slope to find the next point. So because it's a positive slope, I'm going to go up 1 to the right 3, up 1 to the right 3. And I've run out of room, but I have 3 points, so I can make a nice accurate graph. And I have a line that looks like that. So that's a positive slope, and that one's not very steep, but that's how we can graph a line in slope-intercept form. Let's try to graph a system now, and we'll talk about the different types of solutions we might come across. So here's our first set, and in this set we have the equation y equals x plus 3, and the blue equation, which is y equals negative 1/2 x plus 6. So I'm going to graph these the same way I did the other two problems. I'm going to identify the slope and y-intercepts of each equation, then I'm going to graph them. In the green equation, m equals 1 and b equals positive 3. So I've got a positive slope of 1 and I've got a y-intercept of 3. So I'm going to graph those. I'm going to start at the y-intercept, then up 1 to the right 1, up 1 to the right 1. And I end up with a line that looks like that. So that's no different than what we just did before on the previous problems. The difference now is that I'm going to do this again with the blue equation. So my slope here is negative 1/2, and my y-intercept is 6. So I'm going to start at 6 on the y-axis. I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and I'm going to graph this line. You can see I have something that looks like that, but I have this area here where the two lines intersect. So this system of equations has a solution. It's the point where the two lines meet. So I need the coordinates for that point that I just highlighted in red. And the points for that are 2, 5. 2 on the x-axis, 5 on the y-axis. So my solution here is the point 2, 5. That is the only solution because it's the only point where they intersect. Okay, let's look at no solutions. If we have a system of equations that has no solution, we can often tell by looking at the equations because the slopes will be the same, but they'll have different y-intercepts. And what that means is when we graph them, the lines will be parallel. So I'll go ahead, I'm going to graph the green equation, which is y equals negative 2x minus 1. So my slope is negative 2, my y-intercept is negative 1. So I'm going to start at negative 1, down 2 to the right 1, down 2 to the right 1. And I'm going to graph that line. Looks something like that. And then I'll graph the blue one, and I have a slope of negative 2 and a y-intercept of positive 3. So start at 3. I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. I'll repeat that pattern. And you'll see now, look, it's pretty obvious when I graph this, I have two parallel lines. And we know that parallel lines will never meet. So because these lines never meet, there is no point where they'll intersect, which means no solution. Now, I can see that on the graph that they're parallel, but again, I can tell just by looking at the equations, because in systems of equations where there's no solution, the slopes are the same, but the y-intercepts are different. The last type of system of equations that we'll come across is infinite solutions. And all this means is that the lines are the same. And if the lines are the same, that means every single point will be a point of intersection. So I'll show you what I mean by that. Let's look at the first equation, which is y equals 2x plus 4. So this has a slope of 2 and a y-intercept of 4. So I'm going to start at 4 on the y-axis. I'm going to go up 2 over 1. Just going to go in reverse now to add some more points. There we go. Now here's my first line. I'm going to make this one a little wider. So there you can see the line. Now I'm going to graph the second equation, and we'll see that it'll overlap. One thing I noticed, though, is that this is not in slope-intercept form. Slope-intercept form would be y equals mx plus b, and this is y minus 4 equals 2x. So I'm just going to rewrite this so that it is in slope-intercept form. So I'm going to add 4 to both sides, and you can see I've got y equals 2x plus 4. And now it's pretty obvious that they're the same, but just to show you, when I go to graph it, again, the slopes are the same, the y-intercepts are the same, and when I graph the line, it goes directly on top of the green line. They overlap every single point. There's an infinite number of solutions there. So this is our introduction to systems of equations through graphing, and that's what our practice problems are going to be on today. If you have any questions, email me, and I'll get back to you as soon as I can, and I'll be monitoring your work on Mathspace to see how you're doing. Good luck.